Hello everyone, I'm Harshini and Raj, studying in Sri Venkateswara College of Engineering, Bangalore. And in today's video, we'll be seeing about cryptography. The topics covered in today's videos are: first, we'll have an introduction, why we need the ciphers, Caesar cipher, Playfair cipher, Hill cipher, and then we'll have an overall summary to the topics we have covered today. First, we have introduction. Cryptography, the art and science of secure communication, has been a cornerstone of human civilization for centuries. As societies evolved, so did the need for secrecy in communication. Whether protecting sensitive military strategies, confidential business transactions, or personal messages, the fundamental goal of cryptography remains unchanged: to encode information in such a way that it can only be deciphered by those with the proper knowledge or key. This introduction delves into the world of basic ciphers, showcasing three notable examples: the Caesar cipher, the Playfair cipher, and the Hill cipher. Before exploring these ciphers, let's first understand the compelling need for this cryptography. Need for ciphers. Throughout history, individuals, organizations, and governments have vital reasons to conceal their messages from prying eyes. The need for ciphers can be summarized through these key points: secrecy and confidentiality. In an era of information sharing and data transmission, maintaining confidentiality is paramount. Ciphers ensures that sensitive information remains private and inaccessible to unauthorized individuals. Security in warfare. Military operations often hinge on the element of surprise. Ciphers have played pivotal roles in concealing battle strategies and troop movements, enabling comrades to gain a tactical advantage. Financial transaction. In the realm of finance, confidentiality is crucial. Cipher safeguards financial transaction, protecting both individuals and institutions from fraud and theft. Now let's explore some of the foundational ciphers that have shaped the field of cryptography. We'll talk about the ciphers which we are going to be talking about today. Is this of one Caesar cipher, that's the substitution cipher; Playfair cipher, that's the digraph substitution cipher; then the Hill cipher, which is the matrix based substitution cipher. Caesar cipher. Named after Julius Caesar, this cipher is one of the simplest and the oldest encryption techniques. It involves shifting each letter of the plain text or fixed number of position down or up the alphabet. While easy to implement, it offers limited security due to its vulnerability to brute force attacks. Working. First, we have encryption. In encryption, we apply formulas by character based on the alphabetical order. The formula of encryption is En of x is equal to x plus n mod of 26. Now we have an example here where a is equal to 0, b is equal to 1, and n is equal to 3. Working. Now how the message is decoded. We apply decryption formulas by character based on alphabetical order. The formula of decryption is Dn of x is equal to xi minus n mod of 26. This is how the decrypted code will be visible. Next type of cipher, we have the Playfair cipher. The Playfair cipher is a digraph substitution cipher that uses a 5 cross 5 grid of letters to encrypt plain text. It offers strong security compared to the Caesar cipher as it operates on pairs of letters rather than individual letters. However, it has its vulnerability, such as difficulties in handling certain character and maintaining the secrecy of the key. Working. Suppose the plain text is communication and the key that we will use to encipher the plain text is computer. The key can be any word or phrase. Let's encipher the message communication. First, we're going to split the plain text into the digraph by rule 2, that is COMXMUNICATE. Construct a 5 into 5 key matrix by rule 3. In our case, the key is computer. Now we will traverse in key matrix pair by pair and find the corresponding end cipher for the pair. The first digraph is CO. The pair appears in the same row by using the rule 4. CO gets end cipher into the OM. The second digraph is MX. The pair appears in the same column by using rule 4. MX gets encipher into RM. Same way, the third digraph is MX. MU, and it appears in the same row, so it's the same rule. Then we have the digraph NI appears in different row and different column, but here we're going to use the rule 4 of 3. NI that gets the NI gets N cipher to SG. The next we have the CA that appears in different row and different column, so therefore the CA gets encipher into PT. Next we have the TE appears in the same row, so as usual TE gets encipher into ER. Next, we have the Hill cipher. The Hill cipher is a more complex cipher that uses mathematics to encrypt and decrypt messages. It provides strong security compared to earlier ciphers but requires both the sender and receiver to possess the key matrix. Its complexity makes it resilient against many basic cryptanalysis techniques. Working, we have to encrypt the message act, that is the number of letters is 3, so therefore n is equal to 3. The key is GYB NQK URP, which can be written in the n into n matrix. The message act is written as vector. This is how the message is represented in matrix and as vectors. Working, the enciphered vector is given as the following diagram, which corresponds to the cipher text of POH. In summary, ciphers are cryptographic techniques used to encode and decode information, ensuring that sensitive data remains confidential during transmission or storage. These ingenious systems have played a crucial role in the history of communication and security. The fundamental concept behind ciphers involves substituting or rearranging the characters in a message according to a specific algorithm, making it unintelligible to unauthorized individuals. And that and while ciphers have historically been used for military and diplomatic purposes, their application have expanded significantly in the digital age. Today, they are essential for securing communication, online transaction, and data storage, forming the backbone of the cybersecurity. As technology continues to advance, the study and development of cipher remains critical in the ongoing battle to maintain data security and privacy in an increasingly interconnected and data driven world. And that's all in today's video. Thank you for watching.